Hey guys, in this lesson we're going to review how to name chemical compounds. The first question you should ask yourself when you see a compound and you're asked to name it is this compound ionic or not? Well, how do you know? You got to remember that an ionic bond forms between a metal, or a positive polyatomic ion, and a nonmetal, or a negative polyatomic ion. Also, you need to remember that a covalent bond, so something that is not ionic, forms between two nonmetals. If you look at the periodic table, this will help you understand which of your elements would be considered metals and which would be considered nonmetals. So if you have a bond between an element from this side of the periodic table and an element from this side of the periodic table, that means that you have a metal bonding with a nonmetal, also known as an ionic bond. If you have two elements from this side of the periodic table bonding with each other, that means that that bond must be considered covalent because that occurs between two nonmetal elements. So if you have an ionic compound, if the answer to your question, ionic or not, is yes, you must have a bond between a metal and a nonmetal, or have a compound that has at least one polyatomic ion in it. So these are some compounds between one metal and one nonmetal. If you look at this, your one metal is iron and your one nonmetal is oxygen. In the second compound, you see you have your one metal and your one nonmetal. Lastly, in this example, your one metal and your one nonmetal. Okay, well now, if you have a polyatomic ion in your formula, that means it might look something like this. You can also understand by looking at your compounds when you have a polyatomic ion based on how many capital letters you see in the formula. Because you need to remember that when you see more than two element symbols, also known as more than two capital letters in the formula, that means you must have a polyatomic ion somewhere. Well, how do you find the polyatomic ion? So in this example, NH4, this is a polyatomic ion that you need to know that is called ammonium, NH4 1 positive. This is a polyatomic ion. Bromine is the nonmetal that is bonded to ammonium in this example. In the compound over to the right, magnesium, you know, is a metal from the periodic table. CO3 is a polyatomic ion that you need to be aware of that is called carbonate. So the first thing you should do after you decide you have an ionic compound is see if you have a polyatomic ion, because that changes the naming slightly. So the rules for naming ionic compounds are as follows. Metals are named their element name from the periodic table. You can write the word straight from the box in the periodic table. You have to remember, though, that transition metals get a Roman numeral put behind the name in parentheses so that you can tell others what the charge of that metal is in that specific compound. Nonmetals have their element name just as with like a metal, however, it has the IDE ending tacked on. So most of the examples that you'll do between a metal and a nonmetal will end in IDE. All polyatomic ions, positive and negative, are called by their given name. That's why we spent so much time studying them, so that you can recognize them, find them in a formula, and be able to name them accordingly. So let's do an example. MgO. Magnesium, the symbol Mg, we need to determine if that is a transition metal. So let's look at our periodic table. Time to find magnesium. Well, if we look, magnesium is element number 12, which means it is located on the left side of the periodic table in column 2. It is not a transition metal. So it does not need Roman numerals behind its name. Now the O, if you think about what element name stands for the symbol O, that would be oxygen. Well, oxygen with the IDE ending is oxide. Let's double check everything. No polyatomic ions, no transition metal. Our name is correct, magnesium oxide. Let's do another example, FeS. Well, the first step is to name your metal, and we pull that name straight from the periodic table. Fe is the elemental symbol for iron. Next, we need to determine if it is a transition metal. Well, looking at the periodic table, Iron, number 26, is located right here in the heart of the D block elements, meaning that yes, it is a transition metal. What does that mean for us? Well, that means that we must throw some parentheses and some Roman numerals behind the name iron. Before we try to figure out what Roman numerals go in there, let's name the nonmetal. Sulfur is the elemental symbol, is the elemental name for the symbol S. However, we need the IDE ending, which makes it sulfide. Now, our job is to figure out, okay, so how do we know what charge the iron atom has on it? Well, if you look at sulfide and at the periodic table, you will see that sulfur is in a family with oxygen, which means that it forms an ion of 2-. If iron were to have a charge, it needs to balance out the 2-. Every ionic compound ever, all of the positives will add up to all of the negatives to equal 0, meaning that iron needs to have a 2 positive charge. That being said, we throw a 2 Roman numerals in the parentheses to represent that 2. So our name of this compound, FeS, is iron 2 sulfide. The next example, BaCO3. Something should be going off in your mind right now, a little light up there, saying that I see more than 2 capital letters, which means I have more than 2 elements interacting in this compound, which means I have a polyatomic ion. We need to find our polyatomic ion. Well, I know barium's not one. CO3, that for sure is a polyatomic ion, our good friend carbonate, CO3 2-. So now that we know that we have a polyatomic ion in this formula, let's move on. We need to name our metal. Well, barium. Ba stands for barium. Our next step is to determine, is barium a transition metal? Looking at the periodic table again, you can see that barium, element number 56, is not a transition metal. It is located in group 2. So we don't need any parentheses. Now, we need to name the anion in this compound. In this example, carbonate acts as the negative portion of this compound, meaning that we just name it as the polyatomic ion. We don't change anything, nothing gets IDE, it is just carbonate. So BaCO3's name is barium carbonate. I want you to go ahead and take a few moments to try these example problems. If you can name these ionic compounds, some of them have polyatomic ions, some have transition metals, you should be good for naming ionic compounds. If you are still a little bit concerned about transition metals, I'm going to go through that next before we enter into covalent compounds. Let's do one quick practice with transition metals. Cu2CO3. Well, the first thing I should be telling myself is that I see a polyatomic ion. Hello, carbonate. The next thing we need to do is name our metal. Well, I know that Cu stands for copper. If I look at the periodic table, I see that copper is indeed a transition metal, which means that I'm going to have to put something in parentheses after the name copper. Now I want to name the second part of my compound, which in this case is just carbonate, because carbonate is a polyatomic ion, so I do not change its ending. Now, the question is, well, what charge does the copper atom have in this case? Well, carbonate, CO3, has a 2- charge. If something were to add to 2 negative to equal 0, we know that that something would have to be 2 positive. Well, there's 2 copper atoms this time, though. So in order to get something times 2 to equal 2, that something would be plus or a positive 1. So each copper atom has a positive 1 charge, even though the whole compound has a positive 2 charge overall on the cation side of the equation, or excuse me, of the formula. So the 1 positive of each copper atom is represented by a 1 Roman numeral in parentheses after the copper name. Go ahead and try these practice examples with transition metals. So let's go back to the rules for naming ionic compounds, just as a quick review. Metals are named from the element name, the element name from the periodic table. When you have an ionic compound, you just pull the metal's name, write it down. If it is a transition metal, you need to put in parentheses its charge. You can find its charge by using the pieces that you know the charges of in the formula. Nonmetals have the root of the element name with the IDE ending. So oxygen is called oxide when it acts as O2- in a chemical formula. Lastly, all polyatomic ions, positive and negative, are called by their given name. If you need to review those, you should take some time and review those flashcards so that you learn the names and the formulas. Because you've seen in this example or in these examples so far that not only do you have to be able to recognize and name it, you have to know the charge that it's on the polyatomic ions. So let's go back to this very first question that we asked ourselves when we were given a compound and we decided how we were going to name it. Well, the first path that we took was that, yes, we had an ionic compound. The second path we're going to look down is if, yes, I have a covalent compound. So if you have a covalent compound, you must have a bond between two nonmetals. There's no other way you can get a covalent compound. Some examples of what some covalent compounds might look like would be PBr5, CCl4, H2O, and CO2. The rules for naming covalent compounds are slightly more simple than naming ionic compounds, but there are a few similarities. Just as the metal in an ionic bond, the very first nonmetal listed in the chemical formula gets the name just straight from the periodic table. The second nonmetal, or the second half of the the chemical formula, is named with its element name with the IDE ending, just as the nonmetals were in ionic bonds. This time around, there's no polyatomic ion, so we don't have to worry about that. However, we do have to worry about the prefixes. Now the subscripts matter because these chemicals can bond in different ways. So the small subscripts that you see in formulas, now we have to represent those by naming the prefixes. So let's do an example. CO2. Everyone is familiar with this formula. It is what plants take in to be able to photosynthesize. CO2 stands for carbon dioxide. The carbon atom is named just straight its name from the periodic table, just as we set up here in the first step. And oxygen has its nonmetal root with the IDE ending, but now we've got this prefix in front of it, the di, because we see a 2 in the chemical formula. So the prefix di is represented by the 2 in the chemical formula. These are some prefixes you should begin to learn and love. Mono would be represented by a 1 in the formula, which everyone should know at this point. We do not write 1s when we write chemical formulas. Di is represented by 2, tri 3, and so on up to deca, which is 10. Let's do another example. P4O10. Well, P and O are both a nonmetal, so this is a covalent bond. The name of the element P is phosphorus. But we have more than one phosphorus. So if you go back to that table of prefixes you had to study, you would recognize that the 4 listed in the chemical formula would be represented in the name by the prefix tetra. Oxygen is our second nonmetal. Well, it gets its nonmetal root, its metal or element name with the IDE ending. However, there are way more than one oxygen in this chemical formula, and the prefix for 10 is deca. So the name of this compound, once we are completed, is tetraphosphorus decaoxide. Let's do a couple more examples. Covalent naming is slightly more simple than ionic naming, as there are fewer loops to jump through as you name the compounds. So go ahead and practice these and see how comfortable you feel naming covalent compounds. Let's write the formula for the following compound, carbon monofluoride. This is something you will have to do. Besides naming from a chemical formula for covalent compounds, you will have to write the chemical formula from the name for covalent compounds. So our first step is to determine what our first nonmetal of the formula is. Well, as the name says, carbon starts our chemical formula. Its element symbol is C. If you look down at the prefix chart, you would see that mono is represented by the number 1 in the chemical formula. Well, if you can remember, when you begin a covalent name, you usually do not write the first mono. That being said, we know we only have one carbon in the chemical formula, so there's no subscript after the C. Now, fluoride is represented by the symbol F. And again, we have mono listed as our prefix, which means we only have one fluoride atom, which means that we do not list any subscripts. So our chemical formula for the compound carbon monofluoride is just CF. Go ahead and take some time to write the formula for the following compound names. See how comfortable you feel with this step. So to review the rules for naming covalent compounds, you should first understand that the first nonmetal is named with its element name from the periodic table, just like the metal in an ionic bond. The second nonmetal is named with its element name, but with the IDE ending, just as we did with ionic bonds. The thing that changes now is that there's no polyatomic ions, and that when we name covalent compounds, we must use the prefixes to tell our other friends how many of each element we have in the formula. To review, ionic compounds. You need to find polyatomic ions. They keep their names. It is important that you learn the names, the formulas, and the charges. You need to name the metal atom with a name from the periodic table if you have an ionic compound. Add a Roman numeral behind the name if it's a transition metal. The nonmetals from the periodic table are named with their element name except with the IDE ending. Covalent compounds, they are named similarly to ionic in that the first nonmetal in the formula keeps the name from the periodic table. You need to add the prefix if more than one of that atom is present. If only one atom is present of the first nonmetal, you do not need to write mono. It is understood. The second nonmetal in the covalent compound chemical formula needs to be named with its element name with the IDE ending. Always, always, always add a prefix, even if that prefix will be mono. These are a few problems to get you practicing with naming with not being told the types of compounds. So we've practiced with ionic compounds and covalent compounds separately, but now we want to combine everything and practice all together. If you can do these problems, you will be set on naming chemical compounds.